Given that fn equals 2 to the power n plus 1 plus 3 to the power 2n minus 1, prove by induction that fn is a multiple of 7 for all positive integers n. So for this question, what we're going to do is we first have to do f1 and see if the statement holds true. So f1 would be 2 to the power 1 plus 1, that is 2 square, plus 3 to the power 2 minus 1, so that equals 4 plus 3, that is 7, which is a multiple of 7. Therefore, the statement holds true. For n equals 1. So assume the statement holds true for n equals k. So therefore, fk would equal 2 to the power k plus 1 plus 3 to the power 2k minus 1 is also a multiple of 7, because we've assumed that the statement is true for n equals k. Now therefore, we need to prove the statement is true for n equals k plus 1. The statement must be true for n equals k plus 1. Now, is it true for n equals k plus 1? So let's check that. So fk plus 1 would be 2 to the power k plus 1 plus 1 plus 3 to the power 2 times k plus 1 minus 1, and that equals 2 to the power k plus 2 plus 3 to the power 2k minus 1. Now we can rewrite this as 2 square or 2 times 2 to the power k plus 1, because we are trying to write it in this format, the fk. We try to write it like that. And so we write 2 times 2 to the power k plus 1 plus, if I bring 3 out, it doesn't work because I need to make it no, I got it wrong in the other case. It's 2k plus 1, isn't it? 2k plus 2 minus was 2k plus 1, yeah. So so it looks like multiplication, 2k plus 1. So what I need to do is, if I take 3 outside and then I should take 3 square, then I can write it as 3 to the power 2k minus 1, because 2 plus 2k minus 1 would give me 2k plus 1. So I get this, right? This is all correct. So then I can write it as, 2 times 2k plus 1 plus 3 square is 9. So 9 times 3 to the power 2k minus 1. So I have to put in fk somewhere. So I'm going to write 2 times, if I take it within the bracket, 2 to the power k plus 1 plus, and this is 9 times 3 to the power 2k minus 1. So I can just write, instead of it being 9 times, and there's 2 here, so I can write 3 to the power 2k minus 1. So I've taken 2 out of that 9. So I am left with 7 times 3 to the power 2k minus 1. Now that equals 2 times fk plus 7 times 3 to the power 2k minus 1. Now you see this fk is already a multiple of 7, and this is also a multiple of 7. So this is fk is a multiple of 7, and 7 times anything would always be a multiple of 7. So therefore fk plus 1 is also a multiple of 7. So the statement holds true for n equals k. The statement also holds true for n equals k plus 1. Therefore, the statement holds true for n equals k plus 1. Therefore, it must hold true for all positive integers n. So then our proof is completed. We have proved it.